Okay, good evening, ladies and gents. Welcome to the BeeQuant's team's DevOps team demo. I am Boris, and then I am the team leader of the BeeQuant DevOps team. And then because our application is still under development, so this demonstration will mainly focus on DevOps infrastructure and design. So we also have 3 other team members. They are Lydia, Devon, and Xiaobo. So let me introduce the project tech stack. We have used Next.js as frontend, and then GraphQL as our API, and then Next.js as the backend, and then we've used Yarn as library. And then for the DevOps part, we've made 2 different solutions. One is for ECS, and the other one is EPS. We've used GitHub Actions as CI/CD pipeline. Our source code are stored at GitHub. Our infrastructure code is our infrastructure as code tool is Terraform, and then we've used Grafana as monitoring and logging visualization tools. We've also used some experimental tools like OpenCV and Crossplane to provision and maintaining infrastructure. So next, I am going to let David to demonstrate our front end.
下一个发言的是 Devon 同学，对吗？你站到那个喇叭的位置就可以了。
在这里住在
现在可以了吗？
现在能听到。
OK，
好，可以开始。
我们开始吧。OK。For the front end, for the front end in particular, we choose S3 and Cloud Fonts for the following reason. One is the low latency. The Cloud Font can reduce the latency by serving content from the nearest each location of the end user and ensures smooth and fast experience of our users regardless of their location. And the second one is high availability. Cloud Font can automatically routing the request to the nearest edge location. This not only improves the performance but also increase the resilience of our application. And the last one is scalability. S3 also can automatically scale as our front-end app gains popularity. And so for the conclusion, hosting our front-end app on AWS using S3 and Cloud Font can provide a faster and reliable experience for users around the world. Yes, that's finished of my part, and move to the next one.
Okay. Thank you, David. Now microphone comes back to me. So let me introduce the backend architecture for our ECS version. So basically, as you can see, the construction is pretty simple. We have the VPC hosting 5 different subnets, 2 public subnets for hosting the Black Gateway, and then three private subnets. 2 of them for hosting ECS Stargate Vault, and then there's another one in another availability zone to hosting the RDS. Very simple. When user requests the BeeQuant AI, they will be released to Amazon Route 53, and then there's type of record going to Amazon platform distribution, and then it will be taken to AWS S3 as in our client-side rendering website. So then the API will then the user will access to the API, which 3 internet gateway. Then the application load balancer will handle those requests and then distribute them to different ECS bucket pods. We also have Amazon managed CloudWatch to draw metrics and log from ECS bucket, application load balancer, and the database instance. We also have Amazon managed service of Grafana to visualize those metrics and logs. That's pretty much the ECS infrastructure. And then next, we will let Xiaobu to demonstrate the CI/CD part of ECS version.
I'm going to walk you through our CI/CD pipeline setup for both the front end and the back end of our project. Our front end application is continuously integrated and deployed using GitHub Action. Here's how it works. When there is a pull request created to merge the source branch to target that branch, it triggers the CI pipeline. This is the first step in our CI/CD process for the front end. The CI pipeline begins by checking out the code, setting up the Node.js environment, and installing the necessary packages. After that, it runs the tests to ensure that the new changes do not break any existing functionality. Once all tests has passed, the pipeline will proceed to build the application as a static set and cache the build artifact in GitHub Action. When we decided to deploy or update the application, the CD pipeline will be manually triggered. The CI pipeline will be rerun to ensure there is no issue inside of the source code. The CD pipeline downloads the build artifacts from the CI pipeline, configures AWS credentials, and then synchronize the build artifacts to the S3 bucket. After that, it invalidates the CloudFront cache to ensure that the latest changes are served to the users. Now let's move on to the backend. For the backend, the CI pipeline did the same thing as the frontend, so I will introduce the CD part. When we decided to deploy or update the application, the CD pipeline will be manually triggered. The CI pipeline will be rerun. The pipeline builds a Docker image and pushes it to Amazon ECR. We also have Terraform repository contains the AWS Cloud Infrastructure as code, packaging to AWS Cloud account. This workflow is manually triggered as well. This workflow requires you type in environment, UAT or production, case sensitive, and version number. The version number placed in the Terraform repo CD pipeline must be the same as the one placed in source code UAT CD pipeline. Once you put in the correct environment and version number, run the workflow. This will trigger the Terraform configuration, and the new version of application will be deployed or updated to AWS cloud. And next will be Lilia to introduce the monitoring part.
Oh, hello. Okay, let me introduce our monitoring part. We use AWS auto scanning groups, which allows us to automatically adjust the number of EC2 incidents or ECS tasks in response to changes in demand to ensure application maintains optimal performance. Our scanning policies based on CPU and memory utilization thresholds within the CPU and the memory range from 25% to 75%. Next, we also use Amazon's SNS service, simple notification service, which allows us to set up email notifications for all alarms, providing timely alerts on the application's performance and health. Look at the figures. I received the notification that our alarms is less than 25%. This service can send messages to all users while different endpoints. And creating and subscribing to SNS service is free, so it's very valuable. Next. And we also use Grafana, which is an open source platform to monitor and observe the metrics and the logs in our AWS structures. And we can also visualize other data from various data sources like ECS, EKS, database connection, and even network performance. And that's all. And the next part is about the back end.
Okay, thank you, Lydia, for monitoring logging part. Let me introduce our experimental EKS solution architecture, because For this application, in future stages, we might introduce some other microservices. And then, so we decided to make another solution as in EKS, because apparently EKS can definitely handle microservices much better than ECS. So, which is pretty much pretty similar to ECS. We have a VPC, say 5 different subnets, and then to calculate three private. Instead, we have the EKS cluster instead of ECS cluster, which obviously there's going to be more pay, but that will allow us to use some third-party applications, for example, OpenCV. So when user access the backend API, we have the ingress, which is BeeQuant.ai/GraphQL, which will interface with the GraphQL API, and then the user access will be handled to application load balancer, which is the AWS native ingress controller. Then the user access will be handled to local services and then cluster IP services. Then it will go to each application pod. We also have OpenCV as our CD tool rather than using GitHub Actions. So for this EKS cluster, DevOps engineer can also have access to the EKS cluster control plane, because we've set this cluster API to be publicly accessible as well. Then let me introduce the OpenCV version of CD. Because we're not using GitHub Actions to provision the in-cluster resource, instead we use OpenCV. So that will involve 3 different repos. The first one is the source code repo that contains this one is actually pretty similar to the ECS version, which we have a workflow just dedicated to build image and then push it to the ECR. And then we have Terraform repo, which only needs to be run once at the very first beginning of the project, which is to provision all the other resources like RDS and then S3 bucket and so on. Sorry, there's a typo of the S3 bucket. But that EKS cluster is also get provisioned by the Terraform and also the Argo CD application. And then we have a GitHub repo. Yeah. Because we're using Argo CD, so we are using GitHub's procedures. So all changes to the infrastructure must be updated in this repo. So also we have Argo CD to monitoring this GitHub repo. So any changes to the main branch of this repo will be automatically synced by Argo CD. So for example, we have ingress services and different deployments of the application. These are provisioned by Argo CD. Yeah, so yes, I think that's pretty much it of our design and infrastructure. So however, in future stage, we will introduce Crossplane as our infrastructure as data tool, not just infrastructure as code. So there will be also there will be 2 different clusters. So one cluster will host the Crossplane API, and then the DevOps engineer will use that Crossplane's control plane to provision other AWS resources. For example, EKS cluster, RDS, or Argo, not necessarily Argo CD this time, but yeah, that's pretty much it. Sorry, that's it. And then thank you. That will be the end of our demo.